Hi, welcome to my video on explaining positive and negative infinity values of x and y pertaining to the polynomial. Infinity symbol is denoted by this symbol right here, like a sideways 8. X goes to positive infinity, so that means x is moving to the right. So x is moving this way. It can be from any point. Don't make any difference. X is going to infinity, starts on the left and moves to the right. The x values are going to the right. The x values are going to negative infinity is starting over here and it's going this way. So the x values. So infinity means going on forever. Like positive infinity is going to the right, like 10, 100, thousands, tens of thousands, million. Negative infinity is going to the left, starting at wherever you wish, 0, -1, -10, -20, -100. It's going to the left on to infinity. There's no end to infinity. It keeps going on forever and ever. And when we say y is going to positive infinity, that means the y values are going up. And they can going up from anywhere. So they can be going up from -2 up. They can be going up from 1 as long as positive infinity for y is going up. Negative infinity for y is going down. The graph, the points on the graph are going down. So review, x is positive infinity going to the right, x is negative infinity going to the left, y is positive infinity going up, and y is negative infinity. The y values are going down in a graph. Now let's use a combination. What about if we have a polynomial that has the x values going to positive infinity, which means this way, and the y values are going to positive infinity. So that means we have a graph that's doing this. It's going up. So the x values are going to the right, positive, and the y values are going up. And x goes to positive infinity, y goes to negative infinity. So as x goes to the right, which is positive infinity, the y values are going down. So that's how it's going. So x is going to positive infinity to the right, y is going positive infinity up, so you're to the right and up. So this is all the points that's up in this part of the graph. X is going to positive infinity and y is going to negative. That means the graph is going down. So as you go to the right, the graph goes down. And this is the case where a is greater than 0, and this is the case where a is less than 0. Okay, let's continue. More explanations. So what about if we have the x value going to negative infinity and y is going to positive? So that means the x values are going to the left and the y values are going up. So this part of the graph is indicating as you move, x goes to the left, the y is going up. And what about x is negative infinity and y is negative infinity? So as x goes to the left, the y values are going down. So there's part of the graph. So x is going to the left, negative infinity, y is going to negative infinity. So this is the graph. State the end behaviors of each graph. So let's look at the graph. Notice that this graph is a parabola. It has two x-intercepts, and notice that a is positive because it's going up on the right side. So as x goes to positive infinity, then the y values are going to positive infinity. So as x goes to the right, y is going up. As x goes to negative infinity, going this way, the y values are going to positive infinity. And another graph. And again, this graph has a double here, and a single here, and a single here. So it's a parabola. So that's a quartic. So as x goes to positive infinity, out here, the y values are going to go down, so that's negative infinity. And as x goes to negative infinity, as we look out here, the y values are going down, so it's negative infinity. So it depends on the shape of the graph, how it starts and how it ends. Okay, let's do some practice. State the end behavior of each. So we have 5 here on this page. And so as x goes to positive infinity, y is going down, so it's negative infinity. As x is going to negative infinity, the y values here are going up, so that's positive infinity. And in this graph, as x goes to positive infinity, the y is going up, so it's positive infinity. And x goes to negative infinity, what's the y value doing? They're going down, 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 so it's negative infinity. And this graph here, again, notice this is a sideways S, so this is a cube. And notice this is linear, so there's 3 intercepts, so 3 single intercepts because the line's going through, so it's cubic. This is a cubic, but it's something like x minus 2 cubed. This is a sideways S. And this one, as x goes to positive infinity, y is going down, so it's negative infinity. As x goes to negative infinity, this is going down, so it's negative infinity. And again, this is a single, tangent here, double, and a single. So that's a quartix. This graph is a quartix. And this graph, as x goes to positive infinity, y is going up, so it's positive infinity. As x goes to negative infinity, y is going up, so it's positive infinity. And again, this graph here is a parabola, so that's a double. That's going straight through, so that's a single. And that's a single, so that's 2, 3, 4, so that's a quartix. Quartix. And notice this is positive and this is negative. This, I call this McDonald's and this Wendy's, as in hamburgers, where you, franchises where you buy hamburgers in Canada. And number 5, as x goes to positive infinity, y is going to negative infinity. And as x goes to negative infinity, y is going to negative infinity. And notice this one right here. This is a sideways S. This is a double because it bounces off as a parabola. And that's a single because it goes on through. So that's there's 6 power. This is a single, double, and a triple. So that's, we didn't give a name for 6 because normally when you're testing and talking about, you don't talk about polynomials to the 6th power. Okay, now we have another sheet to do. And to summarize all that, I have graph each and state their end behaviors of each. So that's doing what we did in the previous video plus what we have here. So let's look at, we have an x plus 2 equal to 0. So x equals negative 2. We have an x minus 1 equals 0. So x equals 1. We have an x minus 2 equals 0. So we have x equals 2. So if you let this be 0, that's making the y value 0. We'll find the x-intercepts. So you just got to get the opposite sign. So the x-intercepts are negative 2, 1, and 2. So that's the x-intercepts. And because it's positive, the graph is going up from here. So there it is. But to check that out, let's get the y-intercept. Let's let x be 0 and work out each of the brackets just to make sure. So we have a 2, negative 1, negative 2. Multiply that and we have a 4. So that's the y-intercept. That's when x is 0, which I let it, y is 4. So that's, pretend that that's right there. So that's a 4. So the graph is going up from here. It's a linear. Notice they're all linear, so that means there's a 1 and a 1 and a 1. So they go through, comes down, bends, it goes up, keeps going up, and it can go up through the x-intercept like that, and then when you do, it got to come down and go through this x-intercept. There it is there. Now, this could leave here and go on up here further, and then bend and come down, but it has to go through this y-intercept. So it could go up here and bend and come down right here, but so what I did, I just went from here right straight up through here. And to look at that on a graph, what I did, I put them on the graphing calculator earlier. So notice this equation here is x plus 2, x minus 1, x minus 2. That's the first one. I put the 3 of them. I'm going to do 3 of them. So I'm going to graph this first one. See if it looks like this. So notice the x-intercepts are -2, 1, and 2. And notice it's going up from here, coming down, and it goes up through the y-intercept, which is what I did here. Came on up, and I didn't worry about the peak here. Calculus will find that peak, but you don't have to worry about it right now. And then it comes down. So it goes through each of the intercepts with a line, notice, like I did here. Only mine is a little bit, this is the graphing calculator with all the values. Okay. Now let's do number 2, see what that looks like. Oh, we forgot to finish it. And as x goes to infinity, y is going to positive infinity. X is going to the right, y is going up. As x goes to the left, which is negative infinity, y is going to down, which is negative infinity. Okay. And we have another one, the x-intercepts. X plus 1 equals 0, so -1. X minus 1 equals 0, so x is 1. So the intercepts are -1 and 1. -1 and 1. And what's the y-intercept? Well, you let x equal 0. When you let x equal 0 in the equation, you get y equal to 0. So you get 1 squared, -1 squared. So that's a 1, and that's a 1. So it gives you -1. So the y-intercept, when x is 0, y is -1. And that's, pretend, just right there, -1. So notice we got doubles. We got doubles at 1 and doubles at negative. That means it's tangent. Because it's negative, it's going down from here. So there's the negative. You take the furthest x-intercept on the right, and from this furthest x-intercept, you either go up if it's positive, or you go down if it's negative. So here we are going down. So let's go backwards. Now, at 1, which is here, it's a square, so that means it's tangent. So it comes in, bounces off, and when it bounces off, to make a parabola, it has to go through the y-intercept. So it kind of go like that. Then it comes over, and at -1 x-intercept is a double, so it got to bounce off there. So it bounces off, and it comes down. So there's the graph. Notice it's a double and a double, so it's tangent at both places. It's tangent. There's a parabola here, and a parabola here going through this y-intercept. And as you go, x goes to positive infinity, y is going to negative infinity. Y is going down. As x is going to negative infinity, going this way, the y is going down, so it's negative infinity. And I have that graph on here. So I'll go over, and now what I'm doing here, I disengage this one. Notice this one is in black, so this is the one I'm going to graph now. And this is the same equation, again, that I have here. It's x plus 1 squared, x minus 1 squared, with the negative in front. So, graph that, see what happens. And as you can see, it looks just like this one. That's the 1. That's the -1. That's the -1 y-intercept. Notice it goes down, tangent to the y-intercept, tangent. Tangent means there's a parabola, and it goes down. Okay, and let's do number 3. We have an x-intercept that's 0, because of x cubed, just put 0 in. And right here, it's a 2, opposite. Right here, it's a 4, opposite. So we have a 0, and we have a 2. And I'm not particular. I'm just doing this numbers. I could mark them off like that if I want. Now I have them. So the 3 intercepts are 0, 2, and 4. Notice this is a positive, so that means it'll go up from the 4. So here's the 4. You take the furthest x-intercept on the right, which is the 4, and if this is positive, it goes up from this intercept. If it's negative, you go down from that intercept. So here's the graph. There it is as a rough sketch going up from the 4. At 4 is a 1, so it's going on through. It's coming on down. Notice we got to go back through the 2. So at 2 this is a 1. So it bends, it comes back, and there's a 1 here, so it has to be linear, it has to go on through. So as we go up, notice this is a cubic. It has to go back down to the 0. So this is the y and x intercept. So I go up so far, and then I take the bend. It has to come down through the 0. Now, notice the cubic is a sideways S. So I'm going to bend and come down. As I do, I'm going to make a little curve on the side like that. And there it is. So it's a linear, goes on through. This is the linear, goes on through. And because of this sideways S, I call it, that's the cubic. And notice there's 5. Degree of this is 5. So this is a quintix. Degree of this is 4. So that is a quartix. Degree of this is 3. So that's a cubic. And as x goes to, I forgot to get the y-intercept. So if we let x equal 0, I just do this anyway. Just let x equal 0. I have a 0 cubed, which is a 0, -2, -4. Because I have a 0 multiplied by these, 0, that's a 0. So the x-intercept and the y-intercept are both 0, 0. Because that x is by itself, then we put 0 in, automatically y becomes 0. And as x goes to infinity, right here, y is going to up positive infinity. As x goes to negative infinity, this way, the y is going to negative infinity. So that's explaining the end behaviors in terms of polynomial graphs. And as x goes to infinity, the graph will go up or down from the right, depending if it's positive A or negative A. And as you go to the left, to x is negative infinity, the graph either goes up or down. And the next video will explain more on that. And if you like my video, click on the like button, click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.